Hi folks, I'm going to discuss my solution to today's problem in September LeetCoding Challenge. I am Channa Bankapur. I'm a trainer at GoMaster Technologies, and this video is being recorded for the YouTube channel of GoMaster Technologies. So here is the problem. The title of the problem is word break. So the problem has a string S which has at least one character in that, and a dictionary of some, at least one words in the dictionary. And we need to determine if the string S can be segmented into a space separated sequence of one or more dictionary words. In other words, can we partition the string S into dictionary words? That's all they're asking about. And this is a decision problem. So the answer is just about true or false, whether it is possible to do that or not, right? So that should be simpler. And so we have an example here, LeetCode. So that's a string, and the dictionary has leet and then code. So therefore, it can be segmented. So the answer is true. And another example has something apple, pine, apple, something like this. So apple, pen, apple, actually in this case. So apple, pen, apple can be actually segmented that way. So apple is used multiple times. That is okay, right? But yeah, the dictionary is going to have only one instance of apple, but the string can have multiple, right? So that's the problem here. How do we solve this one? This is a decision problem, and there are many possibilities here. The many possibilities of segmenting a string. So I'm going to approach. I'm going to try state space tree approach so that we can see whether we can get into a dynamic programming solution. So I'm going to define a function called, say, f of k. F of k essentially tells me if it is possible to segment the first k letters of string S with just dictionary words, right? That is what the problem is. And yeah, to start with, we're going to call f of n because there are n letters in or n characters in the whole string. But yeah, k refers to the first k characters. So the possibilities are, say, if there are no dictionary words that end at kth character in the string, then we don't have a solution. F of k is going to be false, right? But if there are some words that end at f of k, that means the suffix of the string ending at, say, string of 1 to k, if you consider this as the string, 1 being the first letter of the string. In that case, so we need to look for all the suffixes of s that are present in the dictionary and try for each of them. Each possibility can be, each of them can be the last word in the segmentation, right? So we're going to try each of them. So all of these possibilities, and if any one of them work, that is good. So it's more like or of all of these things, right? Suppose there is at some some L length, we have a suffix. So in that case, it's going to be f of k minus L is what we want to check, because there is a word of length L that is a suffix of this string s1 comma k, and that is a dictionary word, right? So we are going to check for that. So now it depends on, if f of k is false, this suffix is useless. If f of k is true, then the answer is going to be true, because we are just looking for one of the ways of segmenting it, right? So this is the approach, and obviously f of 0 is going to be true, because if there are no letters, that is as good as segmenting it in a way, right? So let's see whether how to write this one. So in my case, I'm going to write f of n as the recurrence. So it's basically if we need to see if there exists so if there exists any suffixes which suffixes of s of 1 to n which are present in which belongs to the dictionary, right? For each of these suffixes, we need to try out. What we need to try is we need to see f of n minus this length of the suffix. We need to subtract so that we try out the remaining part of the string. If this is true, then we need to figure out. So, and then there exists essentially tells us we need to find one of the possible answers here, right? So any one of them is good enough, right? Let's quickly get to coding. It's not too hard to code, looks like. So I'm going to code in C++. So here is Here is the string s and then the word dictionary. So the word dictionary is given as a vector of strings, but I need to keep looking for whether a given substring is a word in the dictionary. So that's a frequent operation. I'm going to use a proper dictionary itself, but yeah, here there is no key value. It's only the key we need to look for. So I'm going to use some kind of set, and even unordered set is also fine. So I'm going to use an unordered set. So unordered set of string. So is what I'm going to use. So this is my set of words. This is a kind of a dictionary essentially, and I'm going to initialize this with all the words in the in the vector. So it's going to be words. Word dict dot begin, because that is the first one. I'm just giving the iterator so that it's going to initialize with all of them in one shot. Right. So this is, so now the words is essentially the dictionary for us, and we can use whether if there is a word is found or not. Right. We don't need any other operations like insert and all, because we have inserted every possible word. Right. Now we need to solve for yeah. So what I explained, that function is essentially a top-down way of actually doing that. If I turn it around and then make it bottom up, it's all about we need to see whether something f of k is possible or not. And when operating for f of k, it needs to access that f of k minus length of the suffix or length of the dictionary word we found as a suffix, right? So that means if all the problems of lesser than f of k is already solved, we don't need that recursive thing. So that is the bottom up way of doing it, right? So what I'm going to do is I'm going to have a table so that I remember the solutions for each possible value of k in f of k. So that is going to be informally called as DP table. So I'm going to use a DP table. So I'll use a vector again, but yeah, each of them is just a bool. So this is going to be DP, and we need a DP of size. So the zero is going to be, so here the index is going to be the length of the string, right? So zero means no value, and then the s dot size is going to be uh, the length of the whole string itself. So the DP size needs to be one more than the size of s. So s dot size and plus one, right? This is the DP size we need, and we need to initialize all of them with say false, and then set the first one to be as DP of 0 is going to be 0 because f of 0 is true. This is what I'm going to set. So that I have initialized the table, and everything else is false. Actually, we don't need to initialize to false also. That is not necessary because we are not going to use anything in the future, right? Okay, maybe let it be there so that I don't have to even set to false if I don't find any candidates, right? So now I'm going to run this one starting from the first character. So which is, I'm going to say start from I equal to 1. So I is not the index to s, it is just the length in a way. Uh, as long as I is less than or equal to s dot size is what I need to go, because I'm using I as more of an index to the DP table. So this is one more than the index to the string, right? So this is what we have. So now we are trying to find f of I, right? F of 0 is already found, f of 1 is the first one we need to find, and so on and so forth, right? And I indicates there are I number of the first I characters of the string is what we are dealing with. Now we need to see whether are there any suffixes. So maybe we can start from the last character itself and see whether it's a suffix. So I'm going to use another loop starting with j equals to, it could be I minus 1 because j I minus 1 is going to give me the length of the suffix we're gonna check in the dictionary. So I'm starting with I minus 1, and as long as j is greater than or equal to 0, we should be able to work with this, right? So j plus plus, sorry, j minus minus, and now what I need to see is um, the, the, the substring starting at j and ending at I, or actually not ending at I, of length I or length I minus j, if that is a suffix, or that is a suffix of f of k, if that is a word in the dictionary, then I can just look for dp of I minus whatever that length of that one, right? So what I'm going to do is, if say in words, so in words, if I want to see whether it is present, so I'm going to use count function. So if there is a word which is a substring of s, so s dot substring, um, s dot substring, which starts at j, because that is the index starting at j, and it is of a length of j minus I, right? Or actually, is it j minus I or I minus j? It's going to be I minus j. That's the length. And if the count of this one is greater than 0, that means it is present. If it is present, what we need to do is, um, we need to see whether we need to see whether what we're going to access is dp of I minus this length, which is I minus j, right? So I minus of I minus j is what we need to look for. All right. So in other words, I minus of I minus j is going to be just j. So I'll just write j. So if dp of j is true, then dp of I is also going to be true, because after that, whatever the the substring between j and I is already a word in the dictionary, right? So what we are going to do is dp. So if dp of j is true, that can be compared like this. If dp of j is true, what we need to do is dp of I we also needs to be set to true. And after we set that, because this whole loop of j is all about finding whether is there any one way of segmenting it. If we already found one here, we don't need to go for the remaining values of j, so we can skip all of them and break out of this loop. So we'll come out of the loop of j, right? So otherwise, if none of is at any point of no point of time this is true, then it means that dpfi is going to be false. Anyway, that is by default already, right? So this is going to do it. And when I come out of this one and covered everything, dp of s dot size is going to be my answer. So return dp of s dot size is going to be my answer. All right, so let's see whether this works. Okay, it worked for the simple case. Let's see if it works for another example they have given here. Yeah, so which has this as the dictionary and something like that. Let me quickly run for this example, or maybe I'll just modify here itself. Say LeetCode. Maybe I'm going to put something here: ABC, ABC, or actually I'm going to avoid that ABC. I just inserted this ABC, AB in this one. If I have a word called ABC, uh, okay, the first one is caught, but I don't have AB. But what if I add, just ODE, so that code is not useful, but this ABC, ABC is used twice, and then ODE is another word. This should be true. Yeah, it is working okay. But if this word is not present, it's not a valid one, because we have leet, we have ABC, and then we have code, but there is no AB, right? And there is no way of actually making it up. If I take ABC, there is no word ODE also, so it should be false. Okay, it gave false. Looks like it is working fine. I'm going to submit it. Yeah, it accepted. So everything works here. All right. Looks like, yeah, this is one of the fastest way of implementing it, right? So it's 98 percentile, and space wise it is okay, right? Now let's quickly see what is the time complexity of this. Clearly the outer loop runs for big of n time, and there is another, this one is also linear, so I'm going to say big of n again. Put together, we are dealing with big of n squared. So there are, yeah, big of n squared is the time we take. Even though the DP table is actually linear size, we actually run for big of n squared. Now it depends on what is the complexity of finding the count of a substring. Even if you assume big of one amortized cost of looking for that, but still look at the string length. The string length is again linear, right? Because it is a difference between I and j. That is as good as j itself in a way, right? We are trying for every value of j in reverse order, right? So that is also linear, right? So we need to process that. So in a way, that's going to take linear time at least. So the overall time complexity is going to be big of n cube for this one, for the same reason, right? But yeah, this time looks like is not very expensive. But I think I see there is a little a better way of doing this one. um, you know this data structure called try, right? So we can use try so that this whole thing can be done in in constant time for every letter there. What I'm trying to say here is, um, instead of so the j thing, when I'm going down here, what if you just traverse through the try, and at any point of time if there is a suffix pointing to that particular word in the dictionary. So obviously try is going to have all the words of the dictionary. Probably we need to insert the words in reverse order so that we always need to find suffixes, right? And at any point of time, if there is a valid word, we can actually go and then check for this one, as in whatever these conditions, right? If there is a valid word, if there is no valid word, you keep going further. And at some point, if that falls off the loop or falls off the tree, that means there are no suffixes with this kind of part as a suffix. So that's where we can stop. And probably that's going to improve. We don't need this operation there. It's going to be done in pretty much constant time there. So it could work in big O of n squared, and also it is on an average case it could be better than big O of n squared, because uh, when there is no, suppose there is a long word like A B C D E. In this case, you are looking for this. Suppose there is a word called D E in your dictionary, but there is, after that there is no other word like C D E or A B C D E or A B C D E. Then once you figure out DE, and when you go to C, so in your try you come through E and then D, and then when you see C, there is no branch with C, so you kind of fall off the tree. So that's where we can stop this loop of J there. But otherwise, in this approach, we don't stop here. We go further and we keep checking whether each of these is a word in the dictionary, right? And that could be the improvement. Looks like not many people have coded that. That's why I got 98 percentile here. I'm going to try that later. Right? Otherwise, yeah. Today is all about getting a quick solution. So I think I got one. All right. So let me know if this solution looks good or if there is any other way of implementation. And if you implement using that try method I mentioned, please share it with me and everyone else. Right. Okay. Otherwise, yeah, this is all I had to share today. All right. So please subscribe to the channel for more updates like this. I keep solving these problems on daily basis. And also I'm going to start another other playlist like dynamic programming and all. So please do subscribe to channel and like the videos. Happy coding. Thank you for watching.